Hi, this is Professor Karchner, and let's talk about serialization. Now, the idea of serialization is the process of saving an object to a stream. And the way this is done is that each object is actually given a serial number. So you may have seen this pop up in your code, which is actually placed in there without you putting it in. And this is basically the default serial number that is created for that particular object. So the reason why the serial number is created is so then if an object is saved twice, then when it's printed out or when it's written to the file, it's only the serial number that's written out instead of having to write out the entire object again. Then when you read it, when it sees the duplicate serial numbers, it knows it refers to that same particular object. If you want to write an object to an object stream, the class must implement Serializable. So here we have an example of a class bank account which implements Serializable. The interesting thing about this interface is that it has no particular methods that you're required to give a definition to. It has a couple of methods that you might be required to give a definition to, but in general, the interface has no particular methods associated with it. All the collection classes that are in the Java Collections framework implement the serializable interface automatically, which means it basically just tells the Java virtual machine how to take this class, or an object of this class, and form it into a stream, or how to read from this stream and create it back into, or reconstitute it back into an object of that class. So any class that implements serializable will then be able to take an object and copy it to an output stream, which is actually what serialize stands for. So I'm taking an object and I'm actually converting it into zeros and ones. And then deserialization means that I'm taking that stream of zeros and ones and reconstructing it back into the original object from the stream. So all of these classes in the Java Collections framework that implement serializable provide a readObject and a writeObject method, which tells the Java virtual machine how to do that. Let's take a look at the ArrayList class, which is part of the Java Collections framework. And you'll notice that it does implement the interface of Serializable. It also provides a readObject and a writeObject method, which describes how to take an ArrayList and convert it into an object stream, and then how to take an object stream and reconstitute it back into an ArrayList. So let's look a little bit at the writeObject method for the ArrayList. So this is going to say how to take an ArrayList and convert it into an object stream. So the first thing that needs the information that we need is what the element count is. So you'll see here's the method call for printing out the element count. Then we also need the array length. So we've taken the length of our object and we're writing that out as well. It is an integer. Then for each of the elements, we're going to write them out one at a time. Notice that we're using the writeObject for each of the elements. And so if I want to have an ArrayList which is serializable, the type of object that I'm collecting must also be serializable as well, so that it has a writeObject method associated with it. So let's take a look at object streams. So the one great cool thing about object streams is you can save entire objects and you can read back entire objects from the stream. So I have the object output stream, I have the object input stream for writing and for reading objects. And just so that you know how these fit into the hierarchy, here is my object input stream, which inherits from input stream. Here's my object output stream, which inherits from output stream. This is the definition of the object output stream from the API. Notice in the description it says that only objects that support the serialization interface can be written to streams. It also says that the method writeObject is used to actually write an object to a stream. And primitive data types can also be used to write things to a stream using the data output methods. So you'll see an example down here where we've used an object output stream. And here I'm using a writeInt. This is a primitive type, so this is a method that comes from the data output class. And here I'm using a writeObject today, which is a string. And string actually implements serializable. and writeObject, which is writing out a date. And so date would have to implement serializable as well. And then it also mentions that any classes that require special handling during serialization or deserialization must actually provide a readObject and a writeObject method. Here's the API definition for object input stream. Same thing, it has to use the serialization. It uses the readObject because this is actually deserializing and taking a stream and converting it back into a particular type of object. So notice that we're using the readInt here to convert into an integer. Then the next thing that we're reading is going to be a string, so it would use the readObject for a string and reconstitute that into today. And then a readObject of date, so the readObject method for date would be used here and then placed into date. Again, identifying that any classes that require special handling have to have a readObject and a writeObject. And specifically, the readObject method is responsible for restoring the state of anything that was written to the stream by the writeObject method. So let's look at an example of how to write an array list to a file. So you've created this array list of type string, and you've called it names. And you want to write that to a binary file using the object output stream. So here I've created my array list. Here I've populated it with some string objects. Now I've created an object output stream. This is the file that I want it to be saved in. And notice all I have to do is say writeObject names, and it automatically goes and finds the writeObject for array list, and it takes this array of strings and converts it into a string. One line of code. Pretty cool. Now the reason that this works is because the elements of the array list were strings, and string implements serializable. Down here you'll see this is the header for string in the API, implementing serializable. So here's the writeObject for array list, and within this writeObject method, it's going to call the writeObject of each of the elements that are in this array list. And so since each of the elements are of type string, and string implements serializable, everything works great. If, however, you wanted to have an array list of bank account objects, this would only work if bank account implemented serializable. So you'll notice it works exactly the same. Here's my array list of bank account objects. I have now populated it with objects. Create my output stream. I want to store it in bank.bin. And then writeObject bank, which is my entire array list. One line of code takes the entire array list of bank account objects and puts it into a string, serializes it. Now let's go in the opposite direction, where we're going to read from the file and reconstitute it back into an array list. So this is referred to as deserializing, and I'm going to be creating an object from a string. It uses the readObject of the ArrayList class, which in turn uses the readObject for the elements in the array list. Since in this case we know that string has a readObject because it implements serializable, then I'm able to create my array list of strings, create my object input stream, which is going to be reading from names.bin, and all I have to say is readObject from my input stream, and it reconstitutes it back into an array list of strings. One line of code. Pretty cool. So now let's see how we'd actually read a file into an array list of something other than a string. So in this case, maybe my bank account. So if I want to deserialize an array list of bank account objects, this will only work if bank account implements serializable, and therefore there is some definition for readObject. So same situation here. I've created my array list, which is going to be of type bank accounts. Opened up my object input stream. Here's the file that I'm reading from. Just readObject based on my object input file. It reconstitutes it back into bank, which is an array list of bank account objects. So how do you create your own serializable classes? Well, we've just seen an example where we saw the bank account, which would have been a user created class. The first thing is that you implement serializable. Serializable does not have any methods that you're required to give definitions to. However, there's a couple things that you have to keep in mind as far as if you must provide a readObject or a writeObject method for that serializable class. If the private data members are just primitive types, you don't need to define the readObject and the writeObject. If the data members are objects that already implement serializable, such as an array or a string, then you don't need to define the write and read object. If your data is more complex, such as a tree, then you're going to need to provide these methods in order to be able to serialize into an object stream and deserialize from an object stream. Here's a really simple example. I've got a class called dog which implements serialization, and here are all the members that I would be storing for this particular object of dog. Notice that I have a string, an integer, and a character. Since these are all primitive members or other objects that implement serializable, such as the string, I do not need to provide a readObject or a writeObject for this particular class. Here's an example of my bank account class, which also is implementing serialization. But the only data members that I'm storing for this particular bank account are an integer and a double. Since these are primitive data types, or at least the data members are already serializable, then I do not need to provide a readObject or a writeObject for this particular class. Now let's look at this class bank, which also implements serializable, and we'll see that the only data members associated with this is an ArrayList of bank account. So we know that ArrayList already implements serializable, and we know that bank account already implements serializable as well. So this class does not require a readObject or a writeObject in order to be able to use the object input and object output stream classes. So based on that bank definition that we saw previous, here's just a demo of using the bank. So I've identified that first bank of Java is going to be an object of type bank. Here's my file. Here I've actually opened up an object input stream for that file. And now I've taken my readObject for my input stream. I have to cast that into a bank, and it now becomes a first bank of Java. So now it becomes a bank. It gets reconstituted. Then down here, I've done a little bit of depositing and some finding and some other types of things. When I'm all finished, then I just write the object, my ArrayList, or my bank, which consists of an ArrayList of bank accounts, just using the writeObject. So what is this? You've probably seen some of this pop up into your code, or you get these warning signs that it tries to put in this serial version UID in it. And basically what this is any class that's associated with a serializable class has to have a version number, which is actually used during deserialization to make sure that the sender and the receiver of the serialized objects are compatible. There's a lot of other information in here that you might find interesting, but basically the idea is that if there's a serializable class, there has to be a version number, and it's used during deserialization to make sure that the way that it was serialized and the way that it's being deserialized is actually compatible. You have the ability to create your own serial version UID if you want, and so then you would have to identify that on both ends, both in the readObject and the writeObject. If you don't provide one, then you get this default serial version UID, and that's essentially what this is. This is the default ID. So let's figure out how we would serialize a binary tree. So here's an example of a binary tree, but what data does the tree object actually hold? So this is actually some code which comes from the public class tree map, just to see what the private data members were associated with this particular tree. And you'll notice that the only thing that it holds is the root. And so what we need to determine is by storing the root, would we have enough information to then reconstitute that tree? Here's the API for the default tree model, so you'll see again that the fields that are associated with this tree, that really it only stores the root of the tree. It does not store all of the elements within the tree, only the root. So just a quick reminder, when we created this class bank account, which implemented serializable, The only items that it held as its private members was an integer and a double. And because they were already serializable data types, we didn't have to actually create a read object or a write object because there was enough information here to reconstitute the bank account object. But for a tree, if we were to only store the private data members, which is the root, it would not give us enough information to be able to reconstitute the tree. Therefore, we must provide a definition for the write object and the read object to determine how to serialize and deserialize a tree based on this root. So let's figure out some ways that we could actually figure out how to serialize this tree. So here's my tree here. So I might first think about, well, how about if I just print out all the nodes in pre-order traversal? So pre-order, which says node first, then left, then right. So we'll see, here's node first, then left, node first, then left, node first, then left, then right, and so on and so forth. So you'll see that this is the pre-order traversal. However, this is not going to work because just by having this list of nodes here, I have no way of figuring out what the structure of the tree is. I would not be able to reconstitute the tree just from having this list of nodes. The reason why just printing out the nodes in pre-order traversal doesn't work is because I don't know when I've hit a null pointer, which allows me then to reconstitute the structure. So I'll go ahead and put something in here which indicates when I've hit a null as well. So I go A, and then to the left B, and then to the left D. Then I hit null, null. So then I go back to the right, which is E. To the left, null, null. Go back, null. Go back, C. Go to the left, which is null. Go to the right, F, null, null. So this is how I get my pre-order traversal, indicating the nulls as well, so I can reconstitute that structure. So let's see if you could figure out what the tree would look like based on this representation. So I know that this is a pre-order, so A would go at the beginning, then I'd go to the left B, to the left D, to the left E, and then hit two nulls, back to the right, and so on and so forth. So I'd be able to reconstitute it in this type of tree because I know A, to the left B, to the left D, to the left E, null, null, G, null, null, back to B, null, C to F, null, H, null, null, null. So this is the tree that would be represented with this stream. So now let's see a way we could take this and actually convert it into a program. So I'm going to take this stream that we were using here originally where I've got my nulls in here. I'm going to convert it so that there is a 1 that sits in front of every node and a 0 represents a null. So because of the way that I need to read something, I always need to read an integer. There's no way for me to know if I was going to be hitting a null or if I was going to be hitting a node. So I read an integer. If it's a 1, I hit a null. I read an integer. If it's a 0, then I know that it is a null. So here's a sample of what my read object could look like. So I'm going to be starting my root here, creating a new node, and then I'm calling a recursive function called tree file read, passing in the root and also passing in this input stream. So now here within my tree file read, I'm going to be first reading the integer. If it's not a 0, that means it is a node. If it is a 0, that means that it is going to be a null. And so if it is not a 0, then I check to see if it's not the root, because I've already created the root here. If it's not a root, I create a new node, and then I set the data to the next item that I created. So if it was 1A, then A would go in as the data. And then I set my left up by recursively passing in the left node, and set my right up by recursively passing in the right node. And this would allow me to be able to take this stream and convert it into this tree. Going in the opposite direction, taking that tree and converting it into a string. So this is my writeObject here. So as long as the root is not equal to null, I'm going to go ahead and start writing with the root and passing that to my output string. So if r is not equal to null, then I'm going to be writing in a 1 and then placing in the data for that particular object. If it is equal to null, then I write out a 0. If I'm writing out my data, then I go to the left, recursively traverse to the left, and recursively traverse to the right. And so it would now take this tree and convert it into this string. This is just one way that you could actually create a read object and a write object for a binary tree. There are lots of other different ways that you could do it as well. This is just kind of a simple way of being able to write the tree into a stream and then reconstitute that stream back into a tree. So anytime you have any kind of data structure where the data members do not have enough information, do not hold all the information that's needed to reconstitute the data structure, then you would need to create a read object and a write object. So a tree is an example. You may need to do that with a linked list. There are other types of complex data structures that you would need to create read objects and write objects for as well, if you wanted to be able to use the object input streams and the object output streams.